Okay, second part of 10.1.
Wait, are we not going back to surface area?
Yeah, I jumped way ahead. I wasn't supposed to do that until after the length of the cycloid.
Oh, man.
So then but so you already have the formula now, so today's lecture will be shorter. Okay, yesterday what we did is we did parametric equations. You were able to figure out how to find the derivative of parametric equation, which you already knew, but then to find the second derivative. And then we have a formula for finding the length, which we could review quick. What is the length of a curve? It's an integral, because you're going to add up all the segments. So it's from A to B, where A and B represent the time or the angle that it's going through. And it's the square root of
Wait, you want one?
the x dt
Squared.
plus dy dt squared dt. Okay? Alright, what is a cycloid? A cycloid is created by taking a circle and rolling the circle with the point on the edge of it. Okay? And it continues. The cycloid will continue. Alright? And so what is the length of it? And it got a little crooked because it's smooth down here. It goes through an angle from 0 to 2 pi, because we went all the way around. Yes?
It's supposed to be symmetrical.
It's supposed to be symmetrical, yes. And it has a pretty unique property. If I was to make the cycloid upside down, like that, and you were to drop a ball from here and drop a ball from there, they would both meet at the same time. Okay? Why? Because this one has a lot farther to go, but it's going to be going faster. And this one doesn't have very far to go, but it just puts along, and they're going to meet at the same place. So it's a pretty neat property. No matter where you drop the ball from, they will end up at the center at the same time. Kind of a unique property. Okay, so what we need to do before we find the length of the cycloid is to figure out the formula for what is a cycloid. So let's evaluate that. So here is a ball. Here is this thing rolled out here, and so this point right here is right at that point. This point here. So I've rolled this thing. And my wheel is sitting right here. You with me? And that's why, I just started. I started here, and I rolled it, and I'm right about that point. So now I've drawn that circle. So this is the point x, y that defines the cycloid. Well, we need to come up with an equation for that point. Well, do you remember how to find the length of an arc when you know the angle and the radius? Freak out. What's the length of an arc? No. Radius times the angle. So, if I choose to do a parametric equations, I'm going to call this angle t. So it's r times t. Okay? Let's take a circle that has a radius of a. And what we just did is we revolved it. So what is this distance here? That's the distance that would be the arc length from here, because that was unraveled. So what would this distance be? If the angle that we went through was t. It would be what? Yeah, a times t. You okay? So the arc length that we just created is a times t, r times t, and that was just rolled out here. So this distance is at. Are we all right on that? All right, so this point here has the coordinates at, comma, a. And what I'm interested in, this is at, comma, a. What I'm interested in is this point. So, I'll put a theta there. What is x? X is the distance from here to here, plus this distance. So it's a t plus what? What would this distance be right here? It's a little tiny triangle. This is theta, this is a, and I want to know this distance. So what do we use? Cosine of theta equals question mark over a. So the question mark is a cosine theta. So this distance right here is a cosine theta. So that's the coordinate for x. All right, what's the y coordinate for this cycloid? Well, the y coordinate is this distance here plus that distance. So this is a, and then what would this be? The two question marks. A sine of theta. Because if you took the sine of theta, you would get two question marks over a. So that distance is a sine of theta. You with me? So now we have a formula for a cycloid. There's a problem with the formula, though. What's the problem? Too many variables. We got to have everything in terms of t. We can factor out the a's, and we will do that. But let's get rid of that theta. So how do we get rid of the theta? We know that t plus theta must equal 270 or 3 pi over 2, or 270. So that means that theta, the thing we're going to replace, is 3 pi over 2 minus t. All right, so now what is the cosine of theta? Well, the cosine of theta would be the cosine of 3 pi over 2 minus t. Yes?
Why is t plus theta equal 3 pi over 2?
Well, this is t, and I made a horizontal line here,
Yeah.
so I've gone 270 degrees.
Okay.
Look at that. Okay. If I was to use the unit circle, and let's say this is angle t. Let's say this was t. 3 pi over 2 minus t would be 3 pi over 2 minus t would be this angle. So, just for argument's sake, if this was 30 degrees, what would this angle be? 60 degrees. Okay? You know, if this was 29, that would be 61. What's the cosine of this angle? The cosine of this angle here is going to be this side over the hypotenuse. What's the cosine of this angle? Not the cosine, but what would be the same answer over here in this triangle? The sine, this side over that side, except that it would be the negative of it. So the cosine of this is the same answer as minus the sine of t. If you take the cosine of this, which would be that would give you the same answer as if you took the sine of the t that was in the first quadrant. So that means we can replace a cosine of theta with minus sine of t. So this is minus the sine of t. So I can put a minus in front. And we can do the same thing for the sine of theta. The sine of theta would be the sine of 3 pi over 2 minus t. But if I took the sine of 3 pi minus t, the sine of this triangle would be this side here, y over hypotenuse. To get the same answer up here, I have to take the cosine of that, and again it would be negative. So negative cosine of t. So basically, what you're saying with numbers is you're saying the cosine of 240 would give you the same answer as minus the sine of 30. And here the sine of 240 would give you the same answer as minus the cosine of 30, if we were using a 30-degree angle. All right? So then this, instead of a sine of theta, it's going to be minus cosine of t. So again, the minus can go in front. Okay?
Sorry, to speak for here yesterday, but how do we get those original equations of x equals at plus...
We're doing parametric equations. We're doing everything in terms of t. So x is equal to a function in terms of t, y is equal to a function in terms of t.
Okay.
And so this particular function that creates a cycloid is going to have an x and a y value. What's the x value? The x is this part of it, and the y is going to be that
How do
part.
we figure out those equations?
I just walked it off. I said this point right here is this distance
Uh-huh.
plus that distance.
Oh, okay.
And then I said, okay, this distance is the arc length that we've gone so far, AT. This distance was the cosine of that angle times A.
Okay.
The y value, how do we get the y value? By going up a distance A and adding to it this distance, which is the sine of the angle times A.
Yeah. Okay, that makes more sense.
Okay, we all right? So now we're ready to find the length of a cycloid. What's the length of the cycloid? It's the integral that goes from A to B. In this case, it was going to be from 0 to pi. We revolve that cycloid, or that circle, all the way around. So 0 to 2 pi. Square root of dx dt. So what's dx dt? Dx dt would be the derivative of this thing here. So a minus a cosine t. And what's the derivative of y with respect to t? It's the derivative of this thing here. Derivative a is 0. And minus a times the derivative of that would be negative sine, so net result is a positive a sine of theta.
Wait,
Sine of t, sorry. So those are the derivatives, okay? So now you just plug them in. You go dx dt, so we're going a minus a cosine of t, square it. Then we plug in dy dt, a sine of t, and square it. So that gives us the square root dt. All right, can you FOIL this out in your head?
Obviously.
A squared.
A squared minus 2a cosine t plus, oh, it's be, wait a minute here, let's see. A squared cosine squared, okay? And then plus a squared sine squared. Is that right?
Wouldn't it be a squared cosine?
No, A squared.